Hi, today we shall be looking at key concepts in inferential statistics. These are some of the concepts we're going to be encountering in the course of analyzing data using inferential statistical tools. Inferential statistics analyzes data in such a way that conclusions that extend beyond the immediate data are reached. This is unlike descriptive statistics that describes characteristic features of a data set. It tries to infer from the sample data what the population might think and is used to make judgments about the probability of an observed difference between groups or samples to see if it is a strong one or one that might have happened by chance. Concepts of hypothesis testing. In hypothesis testing, the major thing the researcher wants to know is if the observed association, or in some cases difference, is due to chance, or rather the likelihood of the observed association being due to chance. This probability is sometimes referred to as posterior or posteriori probability. That is the probability that the hypothesis is true given the observed results. You can also have the prior probability, which is also known as priori. That the hypothesis is true is our belief in the hypothesis before we have the results in question. That's what priori or prior probability is concerned with. Hypotheses are usually stated in two forms, the null and the alternate hypothesis. The null has to do with the absence of what we are looking for. If it is difference, the null is said in no difference, while if it's association, the null is stated in no association or relationship. A null hypothesis may be rejected, but can never be accepted except tentatively, since further evidences may prove it wrong. What it means is that it's safer to say we reject or do not reject a null hypothesis. Group situations. We have three main group situations. We can have one group situation or two group situation or more than two groups. Under one group situation, what happens is that measurement of variables or variable from only one group of respondents or sample is involved. The variables are assessed with respect to other variables, but it has to be within the group. You don't go outside the group in the analysis or in the measurement in the case of one group situation. For example, a study may be interested in finding out the relationship or difference between income and expenditure of a particular group of respondents. This is a one group situation, since income and expenditure are compared for the same group of respondents. Two group situation. This occurs when two groups of respondents are sampled with respect to particular variable or variables to ascertain or find out if any statistical difference exists between the two groups. An example is the test of difference in the rate of purchase of a brand of toilet soap by students and staff of Department of Marketing of University of Nigeria. In that case, you have two groups of two samples, staff and students. More than two groups. There is often the need in research to sample more than two groups of respondents, most times for comparison, and there are statistical tools that have been developed that are appropriate for comparing more than two groups. Nature of groups. Under nature of groups, you can have independent groups and matched groups. Independent groups are groups that have separate populations. The population of one group is entirely different from the population of other groups. Those groups are said to be independent. For example, if two samples are drawn from two different populations, where first population is made up of students and the second population may be made up of workers, in that case, you have two groups, and those two groups are independent. For matched groups, these are groups whose populations are not separate or are non-independent. The population of one group is the same as the population of the other group. This occurs in situations where a group of people are sampled more than once. For example, the same group of students may be sampled on purchase rate for two brands of toilet soap. In this case, it's the same group of students, but you're looking at their purchase rate for two different brands of toilet soap. And most times, the essence of this is to make a comparison. And in this case, you can make a comparison on the purchase rate of the two brands of soap. This analysis is said to have or to involve a matched group. Evaluating hypothesis testing and the role of chance as inference. Hypothesis testing is based on theories of probability and chance. Theories of probability and statistics were born in the gaming parlor of Monte-Carlo and came of age around the 1920s. With the help of the computer and the revolution it brought about, we all have helped to extend this theory. Somehow in everyday life, we are all involved in one way or the other with theory of probability, theory of chance, and also statistics. In analyzing hypothesis test for significance, there are two types of error that one encounters. The first one is type 1 error. It's also known as the alpha error, and it is the probability of rejecting a true hypothesis. What it means is that you conclude incorrectly that data are consistent with the model, and is often written as HO. Type 2 error, or the beta error, is failing to reject a false hypothesis. And what it means is that you conclude incorrectly that data are consistent with the model. In this case, the null hypothesis, HO, should be rejected if the probability is low. Possible outcomes of tests of a hypothesis. We have 4 possible outcomes: rejecting HO when HO is false, which is a correct outcome. The second one is rejecting HO or a null hypothesis. When HO is true, you're not supposed to reject a true hypothesis. If you do that, you commit an error known as type 1 error. Times is also called the alpha error. The third case is you do not reject HO when HO is false, which is an error, and it's type 2 error. The last one is HO is true, and you do not reject HO, which is a correct outcome. The p-value, also known as significance level of a test, and the alpha value. In the course of carrying out hypothesis testing, we have to make use of two numbers, the p-value, also known as significance level of a test, and the alpha value. The p-value, as the significance level of a test, is the result of the significance test, which is the probability of type 1 error given that HO is true. This probability helps us to take decisions to reject or not to reject the null hypothesis. The second value we encounter is the alpha values. Alpha value is the threshold against which we compare our p-values to reject or not reject the null hypothesis of a statistical test of significance. Alpha values are associated with the confidence levels of our test. And the formula to compute alpha, where the level of confidence is given, is alpha equals 1 minus C, which is level of confidence, divided by 100. Level of confidence most times is given in percent. For example, at 90% level of confidence, alpha is 1 minus 0.90, which is 0.10. And so on, like at 95% level of confidence, alpha is 0.05. At 99% level of confidence, alpha is 0.01. So you can see when you obtain significance level of a test, you now compare with alpha. In social sciences, we have alpha of 0.05, which is 95% level of confidence. Sample size, value of parameter affects significance level of a test. Let's look at statistical power and sample size. Statistical power or power of a test refers to the ability to detect an association of interest in the face of sampling error. And this is the same as the probability of correctly rejecting a false hypothesis, usually the null hypothesis. And the probability of not rejecting a false hypothesis is known as the beta. Power of a test, therefore, equals 1 minus beta, which is the probability of type 2 error. The power of a test depends on several factors, just like the alpha, including choice of alpha, the sample size, and the value of parameter. With this, we come to the end of our lecture on inferential statistics and hypothesis testing. Trying to look at key concepts which will help us as we carry on in our hypothesis testing. Thank you.